Hello students, welcome to the physics class, and this is your first class where we will start with the first chapter, frame of reference. Myself, Dr. Jyoti C.K., Assistant Professor, that is Department of Physics. So now directly going to the frame of reference. So first we try to know some of the terms. What is that? Let us consider now a body, means an object, changes its position. Let us consider the 2 points are there. Make an imagination, 2 points, A and a B. Now the body is at the, or the object is at the point A here. If this point, the object which is at the point A moves from A to B, means what has happened there? It has changed the position and it also taken a time here. Then what we say? The body is now under the motion. Otherwise, it will be under the rest position. Okay. Means the state of the motion or the rest may be either absolute or the relative. Let us consider here when the body moves with respect to the point. Let us consider a body or an object. It is now moving with respect to the point which is a stationary. Then what we say here? The moving body is an absolute motion. But in a universe, no point is under the rest here, which is always a rest, absolute motion. It is under the, it is not going to become a rest here. For example, if you consider the sun, moon, earth, star, etc. What are these? These are all the moving. They are all the moving object. A sun, moon, earth, star, they are not under the rest position. They are under the motion. So here, no body is at a permanently in the state of a rest in this universe. Means an absolute rest is only imagination. Okay, student? An absolute rest is only the imagination. Means when I told the state of the motion or the rest can either be the absolute or the relative. Absolute, do you understood the absolute here? Absolute is only the imagination. We say that object is under the rest. It is only the imagination. When we look at this sun, moon, earth, they are all under the motion. So the absolute rest is only the imagination. Okay. Now both the rest and the motion, they are the relative. So, if the college, let us consider the college building, it is at the rest. With whom? It is at the rest with respect to the earth. When you compare the college body with the earth, we say that the college building will be under the rest position. But actually what is happening? The earth is moving with respect to the sun here. So, in order to describe the motion of the body, one has to specify that with respect to what the motion is measured. Okay, now we say the object is under the rest, means for that we have to compare with another one. When you compare this building with the earth, we say the building under the rest. But when actually we know that the earth is under the motion. So, in order to describe the motion of the body, one has to specify that with respect to what the motion is measured here. So, if we imagine a coordinate system attached to the rigid body is nothing but the not flexible. Then we describe the position of any particle in a space related to it. Then such a coordinate system, we call it as a frame of a reference. So, the simplest frame of reference is a Cartesian coordinate. As we know, the Cartesian coordinate means like three coordinate systems will be the X, Y, Z. Already have studied in the PUC. X, Y, Z. That is the position of the point is represented by the 3 coordinates like X, Y, Z. So, the frame of reference is of the 2 types. One is an inertial frame of reference. Another one is a non-inertial frame of a reference. Okay. The frame of reference means here the initial frame of reference means what here? The frame of reference in which the Newton's first and second law will hold good here. That we call it as an inertial frame of reference. Okay. The inertial frame, an example, the body is either at the rest or else it is under the uniform translatory motion. That is an inertial frame of reference. The second one is a non-inertial frame of reference. Non-inertial means opposite to the inertial. What is that opposite? Non-inertial frame of reference is the one in which the Newton's first and second law will not hold good. Okay. For example, accelerated and rotating frames are the non-inertial frame of a reference. So till now we learnt about this frame of reference. What do you mean by the frame of reference? Again, the frame of reference is of two types: inertial frame of reference and a non-inertial frame of a reference. So next we will move with the another one, that is a Galilean transformation. Okay. Now Galilean transformation. So here, at any instant, let us consider now the point or an event. The point, or maybe it an event, has a different coordinate in a system. In a different system means different coordinates will be there, in a different systems will be there. So the equation which is providing the relationship between the coordinate of the two systems, we call that one as a transformation equation. I will show now what do you mean by the transformation equation. Okay, in a forthcoming class. So now, here the transformations of the coordinate of an event from one inertial frame to another inertial frame, that we call it as a Galilean transformation. The name indicating a transformation. The transformation of the coordinates has to move from one inertial frame to another inertial frame, that we call it as a Galilean transformation. Transformation equation means what here? The equation which is providing the relationship between the coordinates of the two systems. The two systems will be there like x, y, z and x dash, y dash, z dash, and the equation which is relating between these two coordinate of the two systems, we call that as a transformation equation. Galilean transformation, what here? The event has to change from one inertial frame to another inertial frame. Then we call it as a Galilean transformation. So that will become clear when we look at this figure. Okay. Here we can see now, this is a Cartesian coordinate system. X-axis, this is x-axis, y-axis and a z-axis. Similarly, again here, y dash, z dash and an x dash. X and x, x dash and x both will be coinciding along this one, and the 2 points are there, O and O dash. So here let us consider now two system of the reference. What is that? S and an S dash here. S and an S dash. So here S is at the rest. This S is under the rest, whereas S dash is under the motion, with which it is moving with the uniform velocity, that is a small v, with respect to the, or else with related to the S here, but it is in a opposite direction. It is in an opposite direction of the x-axis. Now assume that x-axis of both the system always coincides. Already have shown here x is there. I have not shown the x dash, but what we have to make an assumption here, that both the systems always coinciding here. So the x and x dash both are lying on this axis. Whereas this is along the y dash and this is along the y. This is a z and this is a z dash. So now P, let us consider now P here. The P be the event which is to be measured from the both the system. We have to make a measurement of this event P from both S dash as well as under the S system in terms of a Cartesian coordinate. In terms of the Cartesian coordinate. So let us consider now origins. What is that origin? O and an O dash. So now let us consider here. I have written now O and an O dash systems coincide. Already I have shown here in this figure now. O and an O dash both are coinciding along the x-axis. So after some time, now the event P which has to be measured from the system S system whose Cartesian coordinate are represented by x, y, z. S dash system having the x dash, y dash and a z dash. Okay. And it is moving with respect to the certain time here. The S is moving with the certain time is a t. For the S dash system, the time taken will be the t dash. Now referring to this figure 1. So this one I am telling here, referring to the figure 1. Now the relation between the two coordinate system, you are going to write it now. I will show here now. Here what we have written, x dash is equal to x minus v into t. How here? I will show now. Here this is an x dash. Look at here, from the point event P, it is separated by the distance of x. from the S dash to the P, it is separated by the distance of X dash. And this S dash is moving with the uniform velocity, that is the V. And here, it takes a certain time from this point to this point, that is from O to O dash, it is separated by the distance of Vt. So now we wanted to calculate this distance here, X dash. To get this X dash, what we have to do? X minus Vt. X minus Vt will give us a distance of X dash. So I have written here now, X dash is equal to X minus Vt. Whereas for the Y and a Y dash, we can write it here simply. Y dash is nothing but it is equivalent to Y here. Z dash is nothing but it is equivalent to Z here. And T dash is nothing but it is equivalent to the T here. Means this is the observation which we made from the system S dash. Okay. These are the observation made from the system S dash. Which of the event P here in terms of the coordinate of the system S here. Similarly, let us now observation should be made from the stationary system. Which is the stationary system? S is under the stationary. S dash is under the motion. So now we have to make an observation from the stationary system, that is a S, in terms of the coordinates of the moving system. Now we have to compare this with this one. Okay, how we will write now? We will show here now. So this set you consider as an equation number 1. For this whole set you consider as equation number 1. I have written here X is equal to X dash plus Vt. So I will show here in this figure. That is, now we want to calculate the distance of the X here. So this distance X, totally from this distance X is nothing but X dash plus Vt. Both will combine together, we get this X here. X dash means when you subtract this and this, we get the X dash. Keep it in your mind, student. X dash is nothing but separation between these two. Capital X is nothing but combination of these two. So now what we can write here simply, X is equal to X dash plus Vt, Y is equal to Y dash, and Z is equal to Z dash, and T is equal to T dash. So this you consider another set of the equation number 2. So now the equation 1 and 2 that we know it, that we are going to call it as a Galilean transformation. So from these two equations, one can transfer the observation of the event from one system to the another. Okay, so till now we learnt about the frame of reference, inertial frame of reference, non-inertial frame of reference, and Galilean transformation. Okay, so next we continue with the another. Again, the still continuation part is there for this Galilean transformation, because one has to, from these two equations, means comparing the equation number 1 and equation number 2, one can transfer the observation of the event from one system to another. Means we have to make a distance measurement, velocity measurement, acceleration measurement, force measurement. Then we have to look at that whether it is a variant or the invariant. So these all we will discuss in a next class. Okay, students.